Hey students, Mr. Halpern here. So I thought it would be good for us to go and do a review video just to watch and see particularly how we do um, converting units with certain powers like squared or third power cubed. Um, we do this often because when we're talking about something that is squared, we're going from things like a distance, right? So we have a distance here, let's say this is like, a meter, right? Well, we could talk about distance like that, like if you're traveling in a car, meters or miles or something like that. But then we also want to talk about in science other things that have to do with two dimensions. So like if I was trying to figure out an area for a particular plot of land, let's say, it would be measured in meters here and meters here. And to describe this whole area, I would say that there's a certain number of meters squared, right? Because to figure out the area, we do length times width, which is a distance squared. And then finally, we also have cubed. So if I had a third dimension here where we had, where we have like a cube, like we're filling in a box, let's say, okay? If we were to do that, then we would be figuring out volume. And that's what cubed is. It's creating a volume of a particular space. And so that's really important too, figuring out the volume of something, particularly in chemistry. In this case, this would not be cubed, or sorry, squared, this would be cubed, right? Length times width times height. And so that's a distance squared, right? So all of these are really important, and it changes the way in which we can convert units just slightly, okay? So one of the things that I want you to think about is first that you should know that all of this is very similar to what we've done before. For example, if I were to ask you in the first question here, number one, if I were to just ask you to go from 5 meters to centimeters, right? 5 meters to centimeters. Well, what's the relationship there? We should be able to, at this point, now say that there are 100 centimeters in 1 meter, and we know that, okay? Now, if we were to try to solve this question, we would put that in here. We would say that meters would be on the bottom because meters are over here, and centimeters would be on top, and that's the same. Trying to make sure this is working. Okay, so normally I would just put 101 and I would be done. However, this is not, we're not able to cross out the units here because this is meters squared. And I need meters squared and I also need centimeters squared ultimately for my answer. So in order to do that, we have to square the whole thing. And so what this does is it changes our answer here and the way that we set it up. Okay? Actually, if I'm going from 5 meters squared, I have to distribute this squared, right, to everything that's on the inside, right, including also the bottom too, right? So this would also be squared and squared as well. And so the way I should be writing this is I should be writing 100 squared. 100 squared is 10,000 centimeters squared. And then 1 squared is just 1, and then meters squared. So what this is saying is that if I have an area now of a whole meter, right? A meter square meter basically, how many centimeters would fill in that? It's not 100. In fact, it's 10,000 square centimeters fitting into a meter, okay? Squared. And so my answer is if I have 5 square meters, then I would have 50,000 square centimeters. Okay? let's go on to the next one. What if we had this? Using what we just learned, how we have to square things if we have units that are squared. Let's move on to the next one. So we have 10 feet squared, and we want to go to kilometers squared. So in this case, we would set it up, as we said, just like we normally would. So we'd have feet on the bottom. This is feet squared. So where would I go from here to get to kilometers? Well, we know that there's a certain number of inches in a foot. Now, if I have a square foot, not just a foot, but a foot squared, how many inches squared would I have? Well, that changes the number from 12 to 12 squared. So 12 squared is 144. Okay? The only reason why, again, why that number is not 12 is just because we're not talking about feet. We're talking about square feet, or feet to the second power. That's an area, right? A length and a width, not just a single, straight line distance. So we have to do that. Now we're in inches squared, but we're not in kilometers yet. We have to get there. So I have to go to centimeters. So I have inches squared. For every 1 inch, how many centimeters squared do I have? Well, if I just had 1 inch and I was looking at centimeters, I would say 2.54. But this is, again, square inches and square centimeters. So it's 2.54 times 2.54, or 2.54 squared. That's 6.45. Okay. Now we're in centimeters squared. What do we do now? Well, we have to get to kilometers, right? So how do we go from centimeters to kilometers squared? Well, I would go to meters first. If I have 1 meter, how many centimeters there? Right? Well, normally, again, we would say that if there's just 1 meter, there'd be 100 centimeters. But we're talking about a squared meter. So it would be 100 times 100, or 10,000. That says 10,000 here. Okay? And then the last part, let's moving this over a little bit so we can get some space. The last one is, now that we have meters squared, we're going to go to kilometers squared. And hopefully by now you start to see the pattern, right? If I have 1 kilometer squared, it doesn't just equal 1,000 meters squared. It's 1,000 times 1,000. 1,000 times 1,000 is a big number for me to write here. I'm just going to write 100 or 1,000 squared. It's actually a million, 1,000 times 1,000. And my answer would be 10 times 144 times 6.45, and then divided by, right, centimeters, 1,000 or 10,000 centimeters, and a million, right, meters squared. So let me go ahead and do that. 10 times 144 divided by 10,000 divided by 1 million. And that is my answer. Oops, I missed one more step. And then I multiply by 6.45. And I get my answer as 0.00000093. Okay. So if I were to write this in scientific notation, I wonder if I could do this here. Nope. So if I were to write this in scientific notation, it'd be 1, 2, 3, 4, 5, 6, 7. So the answer would be 9.3 times 10 to the negative 7 kilometers squared. All right, last but not least, we have a final problem where we have 20 centimeters cubed per second and trying to go to inches cubed per minute. So with this one, it's cubed, it's not squared, but the same principles apply. We would set this up in terms of units the exact same way that we been doing in every unit conversion. But instead of it squaring the number, right, so the number times the number, whenever we do the number, it's not just that, it's the number times the number times the number, 3 times, right? So let me give you how we would start this. So 20 centimeters cubed, we're trying to go to inches. So what's our conversion factor here? Well, we know centimeters are on top, so I'm going to put centimeters cubed on the bottom, okay? I'm going to leave the seconds alone for a sec, right? Pun intended. But I want to just focus on the distance. So I know that there's a direct connection between inches and centimeters that we've learned, right? Come on. The direct connection is that for every 1 inch we have 2.54 centimeters. But again, this is cubed. So if I have 1 cubic inch, how many cubic centimeters do I have? I have not just 2.54, but 2.54 times 2.54 times 2.54, right? 16.39. Okay. Now I'm in inches cubed, which is great. Now I just have to finish it out by converting from seconds to minutes, which is another single step. Okay? Now seconds and minutes are not cubed, they're not squared, right? So we don't have to change the numbers here. So seconds are down on the bottom, right? So I'm going to put seconds then on the top over here so I can make sure that I cancel it out. Not sure why this is slowing down. And that's 1 minute and 60 seconds, right? So my final answer would be 20 divided by 16.39 times 60. 20 divided by 16.39 times 60. 73.21. And that is inches cubed per minute. Okay? So there we are. Those are our 3 answers, and that's how we solve problems that have squared and cubed in them to convert.